Hello and welcome to the Introduction to ZEN Blue. My name is Dan Stevens and I am an application specialist with Carl Zeiss Canada. The intention of this video is to instruct the user on how to use ZEN to acquire a multi-channel fluorescence image with a motorized microscope. This video will cover launching ZEN, using basic microscope software controls, acquiring a multi-channel image annotations and display settings, and saving and exporting images. To begin, find the ZEN icon on your desktop or Windows Start menu and double-click. If you have a new installation of ZEN, you may find that you have two icons. For a simple camera-based system, you want to select the blue-tinged icon, known as ZEN Blue. The alternative icon for ZEN Black is intended for use with laser scanning systems. While the two are very similar, this video is intended for instruction on ZEN Blue. On launch of ZEN, you will see a splash screen with two options. For instructional purposes, I have all the available options visible. However, on an installed system, you will see only the image processing option and one other. For non-laser-based systems, the second option will be ZEN Pro. For laser-based systems, such as a spinning disk or TURF, the second option will be ZEN System. Launching ZEN in the image processing mode will skip the hardware initialization steps, providing the user the ability to process previously acquired data, but not to control the microscope. Launching ZEN Pro or System will initialize the connected hardware and provide you with the ability to acquire new data. On the launch of ZEN Pro or ZEN System, you should be met with an interface that looks like this. Let's dive right in and acquire an image. To start, we're going to open in the Locate tab. The Locate tab is used for real-time control of the microscope, meaning that whatever we do here is executed on the microscope immediately. When I press the GFP button, for example, although you don't see it, the shutter has opened and the GFP filter has been moved into place. Don't worry if you don't have a GFP button. The ZEN interface can be customized and your system may have been set up slightly differently. We will come back to this point. By activating the Live button, we will now have a real-time image of the sample on the screen. We can confirm that this is a real-time image because of the active Stop button being present, as well as from the camera name appearing in the top left-hand corner of the live image. Because this is a live image, we can immediately see the effect of changing the exposure time or of moving the sample. I will now stop the live window and snap an image. The result is that whatever the camera is currently seeing will be acquired, and a static image will be visible. This image can be saved. Let's close the image and back up a bit to review the ZEN landscape. In general, ZEN operates from left to right, top to bottom. In the top left-hand corner of the interface, you will notice a series of tabs. For the purpose of imaging, we'll use the Locate tab and the Acquisition tab. Finding focus and positioning our sample can be done under Locate, but the more complex multi-channel and multi-dimensional imaging is done in an imaging experiment under the Acquisition tab. Keep in mind, for the purposes of this video, we are assuming you're using a motorized microscope. If you're using a manual microscope equipped with ZEN Light, you'll most likely not have the Acquisition tab. There are a number of housekeeping features to mention before we begin imaging. First, each of the ZEN submenus can be minimized with the window shade type feature, by simply clicking on the blue header of the window. Second, the ZEN interface can be customized. Here I have added buttons for typical fluorophores, as well as to direct the emission signal to either the eyes for the user to see the sample, or to the camera for imaging. These customized buttons should be set up by someone responsible for maintaining the system, and will not be discussed here. Finally, each of the ZEN submenus start with a limited number of tools visible. If you're looking for an additional feature that you feel should be present, click on the Show All button in the top right-hand corner of the window. This will reveal the additional capabilities. My rule of thumb is that if you do not know something is missing, stick to the basic tools to avoid any unnecessary complications. One more comment on the Locate tab before we move on to the Acquisition tab. By expanding the light path, we can see all of the motorized components of the microscope. I'm working on an inverted microscope with a number of advanced components, so don't worry if your light path looks different. By clicking on any of these components, we have direct control of the microscope. As soon as I change the state of that component under the Locate tab, the microscope responds. There are situations where you may want to keep some of these controls handy at all times. The stage control and focus control are two good examples of this. Particularly on some stereo microscopes, it can be nice to have the focus control available as an independent side panel. To do this, simply undock the control window by clicking on the arrow in the extreme upper right of the window that you want to undock. This same undocking can be done with the main windows, but for the sake of keeping the interface neat, I don't recommend it. Okay, let's move on to the Acquisition tab. Typically when working on a motorized microscope, almost all of your time will be spent working in this tab. Here you can see the ZEN interface in the configuration that I would recommend you adopt for your typical use. Notice there are four main quadrants in the ZEN interface window. On the left we have the acquisition parameters that we have set for our imaging experiment. This includes the channels or fluorophores to be acquired, along with the associated exposure times. As well, if we're acquiring a Z-stack, tiled, or multi-position image, we find the parameters here. In the central window, we have the image itself, with tabs down the left-hand side that allow the user to display the image data in various manners. In the bottom quadrant, we have the post-acquisition modification tools, meaning that we use these to change the image after it is acquired. Here we can find the scale bar tool, crop tool, simple measurement tools, and the histogram, to name just a few. Finally, on the right-hand side of the screen, we have a list of thumbnails of acquired images. This provides the user easy access to acquired data and tracks what data has been saved. Let's go ahead and acquire an image, and then we'll back up and describe the various components of the interface in more detail. I'm going to close the open image and then open a live view so that I can double-check my focus and exposure time. I've already found my sample under the Locate tab, so everything should be in good shape. As an aside, this is a good time to mention that there really is no need to start using the system in the Locate tab. You can certainly proceed immediately to the Acquisition tab on startup of ZEN. This is really just a matter of personal preference and what's appropriate for your workflow at the time. I've checked the exposure on my GFP channel, and now I'm going to check for the rhodomine channel by highlighting this as the active channel. More on this later. Once I have my exposure set for both channels, I snap the image. The result is a single image with two channels or fluorophores overlaid. Alright, so using ZEN should really be that easy. But let's back up and discuss how to ensure that this is the workflow your system is using. First, note that my ZEN Channels window was already populated with a number of options. I have 3 fluorophores listed here, as well as a transmitted light channel. I can, of course, use these channels for any equivalent fluorophores. As an aside, if you're new to fluorescent imaging, visit the links that I have displayed on the screen or download the Zeiss iPad app called Light Lab to explore the spectra of various fluorophores. With regards to these default channels, I set these up on any system that I install and train users on, but your mileage may vary depending on how the system has been set up. So I'm going to show you several different ways in which you can populate this window with the channels that you want to image. The first way in which you can populate your experiment, not just with channels but with any number of experimental parameters, is by loading a preset experiment from the Experiment Manager. This is a very simple method of saving your desired configuration. The downside of this is that if you happen to share your system with other users, they can also load and modify your configuration. ZEN does have password-protected users and workgroups, but for the sake of keeping this training to a reasonable length, I'm going to save that for a future tutorial. The way that I overcome this issue is to set up a template experiment. If you click on the cogwheel to the right of the Experiment Manager and then select the New From menu, you will be provided with a list of template experiments. Loading one of these templates, you're immediately required to rename the experiment as your own. Note that the availability of these templates requires that they've been set up on installation, so discuss this with your facility manager or use the 1-800 support line in the comments. There is a second way in which you can populate your experiment with channels, and that is to reuse parameters from a previously acquired image. Any multi-channel image acquired through ZEN that has been saved in the original .czi file format will have an associated Reuse button. Here I have opened a previously acquired image, and on clicking Reuse, you can see that the channels are now populated. Of course, both the Experiment Manager list and the Reuse button assume that the system has been previously configured at some point. So what if I need to create a list of channels from scratch? This is where we want to employ a third method of populating the channels list, and that is by the use of Smart Setup. Smart Setup is a very cool feature of ZEN that requires that the user only know what fluorophores they have on their sample in order to set up an imaging experiment. Here I'm opening a Smart Setup and searching for Alexa 488, Alexa 594, which are going to become the basis of a new experiment. The dye database in ZEN has over 600 options. It is very rare that I work with somebody whose dye is not explicitly named in the database. In this case, of course, we can typically use something we know to be equivalent. So to summarize, we have three methods of initiating a multi-channel fluorescence image setup if the default channels are not available on startup. 1. We can load from the Experiment Manager. 2. We can reuse from a previously acquired image. And 3. We can create an experiment from the ground up using Smart Setup. All of these methods are achieving the same thing, which is to say that they're creating a short script of commands intended to automate the microscope. The detailed list of these commands is available by clicking on the Show All Tools button and then expanding the light path settings. You will find this interface to be familiar from the start of this training, where we saw it in the Locate tab. In this case, however, there are a series of configurations that are executed sequentially, the end result of which is a multi-channel image. While I'm sure some of you will be glad to know that there is this degree of control available through ZEN, I'm showing you this interface largely to tell you not to use it. If you're routinely imaging the same type of sample, there is no reason that you should be repeatedly accessing the light path settings. If for some reason you feel this is necessary, I would suggest you speaking with your local imaging specialist or calling the 1-800 application support hotline. Alright, now that we've established how to acquire a multi-channel image, learning the remainder of ZEN is largely a matter of finding out where the buttons are, and you can likely learn yourself from exploring. I do want to run through a number of these buttons, however, quickly to provide a bit of guidance to that exploration. First, the primary buttons here. The Find Focus button runs an autofocus routine, just as you would expect. Autofocus and focus strategies in ZEN are extremely powerful, so much so that this really warrants an entire half-hour discussion. For our purpose, I will note that you of course require a motorized focus drive such as that found on the Axio Observer Z1 or the Axio Imager M2 or Z2. As well, I will note that you can customize this autofocus extensively in the Focus Devices menu. The Master Set Exposure button here differs from the Set Exposure button found in the Channels window, in that it runs through every channel included in the imaging experiment, and then acquires a snap at the end to view the results. My personal preference is to set the exposures individually through the live image, but this is a nice feature to quickly set up your exposure times, particularly if you have a large number of channels to work through. The third button in this row is the Live button, which we have used extensively, and the only thing I want to note is how it differs from continuous. Notice in the Channels window that there is always a highlighted channel. This is the active channel, and that is what we view when we click on Live. There is also a series of check marks beside the channels. Each channel with a check mark is included with the experiment, meaning that it will be acquired when we snap an image. Clicking on the Continuous button essentially cycles through all of the included channels. For our purposes at the moment, this is not terribly practical, but there may be situations if you have a high-speed imaging system, for example, where this is useful. I will note as well that some cameras intentionally acquire under the live mode at higher speeds than the exposure time would indicate. In this case, using the continuous button will provide a more accurate preview of what the final image will appear as. The Snap button, of course, acquires a single multi-channel image that includes all of the channels that we have checked off under the Channels window. The thing to note here is that it differs from the Start Experiment button. You'll notice the Start Experiment button is currently grayed out. As soon as we add another dimension to this experiment, for example a time series, the Start Experiment button becomes active, and you'll notice the experiment graphic reflects this addition of the time dimension. Clicking Start Experiment will begin the time series multi-channel acquisition, so if we want to preview a single frame, then we use the Snap button. I should note here that the setup of these multidimensional experiments is going to be addressed in complementary videos, so if you're interested, please follow up as is appropriate for your needs. A few points about the channel setup. It is possible to change the colors of the resulting multi-channel image, which can be done here. Should you want to add another channel to the experiment at any time, that can be done through the little plus button that opens up the Smart Setup. Should you have multiple light sources, as is the case on this system, the light source for each channel will be specified here. On this system I have an LED-based light source as well as a mixed halide source. I can select either from my channels and vary the intensity. If this was a laser-based system, I would be able to vary the intensity of the laser from this interface. Many systems have more than one camera, either to achieve different degrees of sensitivity, speed, and resolution, or to switch between monochrome fluorescence acquisition and color cameras for transmitted light imaging of pathology samples. In the Channels window, the camera being used for each channel can be specified here. Keep in mind, if you change your camera, the corresponding light path may not be set up to direct your emission signal to the camera. On multi-camera systems, you can specify your desired camera during the initial setup creation in Smart Setup. Once we begin opening live images of our sample, this brings us to the exposure settings. We can set an exposure for each channel either by manually typing or sliding the exposure time, or by asking the system to set the exposure automatically by clicking on Set Exposure, which ensures that we are using the full dynamic range of the camera. If we are to check the radio box beside Auto Exposure, the exposure time will be automatically set during the image acquisition. Keep in mind that this will slow down the speed of acquisition and increase the total exposure of your sample to the excitation light. During the set exposure process, you may want to see the saturated pixels in your image to ensure that they don't overexpose. You'll find the range indicator checkbox just below the live image. Checking this provides you with a monochrome image that shows saturated pixels in red and pixels with a 0 value in blue. I'm going to snap an image of our current sample so that I can move on to the annotations available after acquisition. Once you've acquired a multi-channel image, you may toggle individual channels on or off by clicking on the channel name under the Dimensions tab. As well, you may change the color of the individual channels if you see fit. The majority of the other available annotations are self-explanatory, but I do want to touch on two specifically. The addition of a scale bar can be done through a single button click. Once on the image, the scale bar can resize as you see appropriate. Any image annotation can be modified for font, color, or size by right-clicking on the annotation and selecting the Format Graphical Elements. It is also possible to change the default values, so this process does not have to be repeated. Cropping an image can be achieved by using the Selection tool. After the selection has been made, right-click and select Create Image Subset. Alternatively, you can use the hotkey Ctrl-Shift-C. This is really the only hotkey that I use routinely in ZEN. I want to point out that when you have the Show All option checked here, it is possible to set the exact size of the crop window, either by dimension or by pixels. I find this to be a really useful feature if you're thinking ahead to the size of your figures on a poster or publication. Finally, there are an extensive number of annotation and measurement tools that can be added to a ZEN image. A small number of the typically used annotations are available here below the image, and more can be found under the Graphics menu in the File menu bar at the top. Now that we have run through basic multidimensional acquisition and some of the more frequently used features of ZEN, I'm going to wrap up with file management, saving, and exporting. The native file format for ZEN is the CZI extension. It is worth noting that some of the most prevalent non-Zeiss imaging software packages can handle this file type natively. That includes Amaris Bitplane, ImageJ, and Velocity. I always suggest that you save your original data in the CZI file type in addition to any other file type that you might want to use for publishing. The reason for this is that all of the associated metadata is stored with the image in this file type, and you'll never be concerned about finding the pixel scaling, for example, if you have the original data. Of course, for publication purposes, we typically want to have a TIFF file format, for example, so let's look at how to obtain that. If we simply select Save As from the File menu, we're provided with the option of saving our image as a TIFF. However, in doing this, we do not retain the image annotations and contrast changes that we may have included in the image. As well, we may want to manage the exported image in some way if we have a large multidimensional image. For most situations, I would suggest saving the data in TIFF format by using the Image Export function. This can be found under the File menu beside Export Import, and selecting Image Export brings us into the Processing tab for the first time in this video. Here we can select the export file type, compression parameters, and characteristics of the resulting exported image that we would like. I would suggest checking the Select All button on this window, as some of the defaults that are otherwise hidden you will likely want to change, such as the fact that the exported image is always included in a new folder for each export. Having saved and exported our image, that now concludes our ZEN introductory training. I fully encourage you to provide feedback in the comments section below, including any requests for future video tutorials. Please look for other future videos, starting with the setup of various multidimensional acquisition parameters such as Z-stack, time series, tiling, and multipoint acquisition. My intention is to include the links in the video description below.